So, to refresh your memory on the background information surrounding John Ball Park, it's a park on the western side of the city of Grand Rapids, and it's been under City of Grand Rapids control since the 1890s. It started as 40 acres donated by John Ball and has developed into a 140-acre park. About a third of the park's acreage is dedicated to John Ball Zoo, which is within the park grounds. That is a zoological garden that consists of all the things that you would expect a zoo to have and is a highly developed and primarily concrete area. The park is mixed use, so there's an educational aspect with the zoological gardens as well as the Grand Rapids Public Schools Zoo School that is run on the grounds. And there's also a recreational aspect to the park. So the remaining two-thirds approximately of the acreage consists of open grassy areas, several park pavilions and picnic structures, two different playgrounds, some tennis and basketball courts, as well as a fairly elaborate hiking trail system through the southwestern corner of the park. As I kind of mentioned, there's a lot of different patches and corridors going on because there are so many different uses of the park, but almost all of them are introduced. Some of the forested areas are remnant trees from the park originally, but many of the features have been, either disturbed or introduced by people. Most notably, the pond did not exist on the property prior to its conversion into a city park in the early 1900s. So that said, we're not dealing with a very natural landscape. We're dealing with something that's highly disturbed. And while that has helped to develop the human use of the landscape, it has really diminished the ability of the landscape to provide necessary ecosystem functions, which we're going to get into here in a second. Through our observations and visits to the John Ball Park, we determined that the problem with John Ball Park is that it exhibits low ground porosity, and because of this, the effects of stormwater at the site must be mitigated. So in its current condition, the stormwater that enters the park has negative consequences for both abiotic and biotic stakeholders. That is to say, the park itself has several locations where water that enters the park, either directly from rainfall or from water that enters the park from the upper areas, is directed to Grand Rapids City sewers, which ultimately lead to the Grand River. So any pollutants that are picked up while it's at the John Ball Park site enter the stormwater system, as well as simply just adding to the load that the Grand Rapids stormwater treatment system has to process. So any particles or anything that end up in that water negatively affect not only the animals at the park, but also contribute to the pollution of the Grand River as a whole. The other component to this is that it degrades the cultural use of the park. So in several places, stormwater that moves over the park surface, because the ground is not porous enough, moves rather quickly and in an uncontrolled sort of manner, and this is causing soil erosion and structure degradation. It's moving soils from locations that are higher up in the park and depositing them in lower areas, which brings its own set of problems. And in a couple of locations, it's causing people to have difficulty traversing the landscape because it's making potholes and washing out trails. And it's also, in one location, threatening a structure. So the stormwater that runs around the upper park pavilion is actually washing out the soil around the base of that, which is threatening the integrity of that structure at the top of that hill. And it's also reducing the aesthetic value. So all these washouts and deposition of soil in places and on trails that should not have soil on them just generally decreases the aesthetic value. Additionally, one of the things that we're going to identify is that water is allowed to pool in a lot of different locations. And so you end up with basically just all these standing ponds in the lower grassy areas of the park. So these pools of standing water, in addition to being unsightly, limit people's use of the lawn areas of the park, because not only is the ponds taking up pretty expansive amounts of space, but also all the ground surrounding these areas is very wet. So if people walk on it, it ends up being muddy. And we've also noticed in our different trips to the park that almost every time that we visit the park following a rainstorm, there are lots of different tire tracks crossing through the lawn because the facility shed where the maintenance equipment for the park is held is kind of in a grassy island. It looks like equipment gets stuck fairly frequently because there are large trench marks that you'll see a picture of in the PowerPoint that are preventing people from being able to do maintenance activities. So being able to divert the water away from areas where it's causing soil erosion, and also to help drain the water out of areas where we want people to be able to do things, is really going to improve the level of usage for the park. So because there's a multitude of different aspects to this overarching stormwater management problem that we're approaching at the park, we need to approach it with a couple of different methods of solution. So the first and the kind of simplest from a design and implementation perspective is plant installations. So one of the things that we've learned about in this class and in some other coursework at Grand Valley is the installation of rain gardens. So we're looking at installing 3 of those in different locations in the park. One of them at the bottom of the trails, the steps that run through the center of the park. One around the base of the pavilion that is experiencing that severe erosion, and one at a central location where one of the biggest standing pools of water is in the park after a big rainstorm. The other category that we're looking at are structural changes, and we're looking at 2 key structures that have water mitigation issues: the Zoo School and the Upper Park Pavilion. And we're considering adding green roofs to these structures to help mitigate the rainwater that collects on their roofs and then proceeds down around the bases of the building. In the pavilion case, that's one of their locations of extreme erosion. And for the Zoo School, there is a nearby storm drain where much of that water runoff is sent to. So adding a green roof will help decrease that there. Also, the surface modifications is a third category that we're looking at editing. So in the actual zoological gardens portion of the park, the primary ingress and egress trail is a sloped concrete section that is the lowest part of the zoo area. And so because of this, any of the water that accumulates on the upper areas of the mostly concrete zoo surface collects and then runs down this walkway across the parking lot and towards the pond, which wouldn't be a severe issue except that it is eroding the soil out from between the paved area and the parking lot and the pond, which is causing basically these potholes that people can potentially trip in if you weren't paying attention to where you were going. And it's also washing sediment into the pond, which is obviously not a good thing. So we're going to kind of explore each of these installations in a little bit further detail as we go on. So this is the overall layout of the John Ball Park. From the orientation that you're looking at the image, north is facing the right side of the screen. The areas at the top of the page on the right side are the zoological gardens. The areas to the left top are the somewhat undisturbed natural forest that has the trail system running through it. The grassy areas immediately below that are the area where we see the greatest amount of surface water present at the site. The zoo school is the building that is sort of in the bottom center of the page, and then the pond is to the right hand side of that. So as you can see, we've kind of detailed out the locations of where we think our improvements would be best served. So the permeable trail and rain garden area is at the bottom of the hill below the pavilion. The pavilion is identified as the pavilion rain garden and green roof. Zoo school is the addition of the second green roof. On the left hand side is the depression rain garden, which is the lowest point in the southern area of the park. And then the primary walkway in and out of the zoological gardens is where we're investigating putting a permeable concrete material to help mitigate that storm water as it runs across that parking lot and into the pond.